Welcome to another unit in business mathematics. This time I'm going to talk about investment valuation. So basically about the question, if I'm going to do an investment, to realize whether this investment is economically sound on the one hand, or if I have two or more possible options, two or more potential investments, to decide which of them is actually more beneficial than the other. Well, how do I proceed with this? First off, what I'm going to do is take a look whether the investment I'm planning is worth what it will cost me. So what I want to do is actually consider the costs and the earnings, calculate thereby the profit, but not the profit at any point, but the profit today. So basically the question, does it make sense to run this investment, to realize this investment today? Well, how do I proceed with this? For each period, what I'm going to do is first off, calculate or estimate the expected returns. Let's call them E. Calculate or estimate the expected payments or costs, and thereby use simple formula, returns minus payments or revenues minus costs, to calculate the surplus or the profit. And then simply consider these profits and discount them back to the present moment, back to period 0. And then we simply add all different payments up, all discounted payments up, and we get the net present value of each of the different investments or options. And that's then basically our profit discounted for today. And if I do this for all different possible investments, I can actually compare them, because now I'm at the same moment in time. They are all listed regarding their worth right now at the present moment. This makes it possible to compare them, even though their duration or interest rates or whatever might differ significantly. Mathematically speaking, means we calculate the net present value by first off considering the investment costs. Here the investment costs are negative because, well, they're costs. And then for each period, I consider here the profits in this particular period. So every time earnings minus costs or revenues minus costs, discounted back to the present. So after the first period, I'm discounting once. After the second period, discounting twice. After the third period, discounting 3 times. And so forth until I'm at the end of my cash flow. Alternatively, I can also write this using the sum formula, which is more or less the same. Still, it's the investment costs. And then I just summarize this using the sum sign. So that's just a shorter version of what we're doing up here. Then we can take a look at an example. Here we have an investor can choose between 2 projects with the following cash flows. The investment itself takes place at time 0. So I'm going to invest today, and either I'm investing in investment A or investment B. If I go with A, I will get cost of 10,000 today. That's why it's at 0.0 minus 10,000. But I will get a return of 6,500 after 1 year and another 1 year later. With investment B, I also have to spend 10,000 and I will get back for 4 years, by the end of each year, 3,800. So first I have to discount this value once, this value twice, this value 3 times, this value 4 times. Whereas here I only have to discount this once, this twice, and add them all up. Well, if I want to discount them back to the present, I actually need to use this interest rate. So the discount factor here is 1 plus this interest rate, then to the power of periods I need to discount. Regarding the solution, first we can start with alternative 1. Here we have the original payment, the costs, plus the discounted profits after 1 period, the discounted profit after 2 periods. If we calculate the last 2 parts, add all of this up, we are at 1280.99. So at this moment we can only see one thing, and that is this value is positive. If this value is positive, this means that this investment is economically sound, because in the end I will be better off than in the beginning regarding my investment or my interest rate I will be charged with for my investment. Okay, this was alternative 1. With alternative 2, I have again minus 10,000, then the discounted first payment, discounted second payment, discounted third, discounted fourth payment. Here, if this line becomes too long, what I can do is I can simply leave the first part as is, and starting from here, I can factor out 3,800 by 1, and I will be left with a small finite geometric series. So here, for example, 1 plus 1 divided by 1.1, 1 divided by 1.1 to the power of 2, 1 divided by 1.1 to the power of 3. Then I can use the formula for the finite geometric series and quickly calculate the net present value of the alternative B as well. Well, as this is already the second of our net present values, now I can get 2 insights from this. First off, due to the fact that it's positive, I can say that this investment as well is economically sound. And second, as this value is larger than the value for alternative 1, this is obviously more valuable than the first one. The big downside we are not going to talk about here is, however, here I only have to wait 2 periods. Here I have to wait 4 periods. So in this regard, that's the only downside, that I didn't actually price the duration this investment will cost. This nowadays might actually be a problem. However, mathematically speaking, I see at this point that the alternative B is better off than alternative A. So my, conclusion here should be both are economically feasible, but alternative B leads to the higher net present value. That's why this version should be realized. Well, that's then everything I wanted to talk about in the context of investment valuation. So I hope you enjoyed it, and say goodbye and see you next time.